Hello guys, welcome to this new video. Today we're gonna be learning, or I am gonna be learning. I'm gonna start this new series on Linux Kernel Module Programming, and it's gonna be probably a long journey, but I'm excited to do it. So, without further ado, let's go on. I'm gonna be using this very famous book that it has been around for several years, and it's like the main starting point if you want to learn about how to do a kernel module. I'm gonna start like delving deeper into the Linux kernel in parallel with other projects that I wanna be working on, like for example mastering C++ and Rust. In general, I wanna learn more about the Linux kernel. So this is one of the few resources that they are around there in the web, and it's like one of the best. So today I'm starting this. I don't know how long it is gonna take, but I'm excited to do it. So let's go on. I already read like the introduction, but I suggest you to read it because it is really good. And I am on WSL for this occasion. I'm gonna be working both from Windows and WSL, and both in Arch Linux that I have on another laptop. But yeah, my main host now it's here because this is my most powerful laptop. But yeah, I am also gonna be working from Arch. Yeah, so I have created a folder here called Kernel Module Programming, and yeah, I'm just gonna start. This is not gonna be a tutorial, by the way. It's gonna be like me doing stuff and exploring, trying to learn something new. Okay, development requires solid foundation in the C programming language, which I don't have arguably, but at least I know something. And I'm not a beginner. I'm also not like a master in C programming. Yeah, from time to time I'm also gonna drink something. So a Linux kernel module is precisely defined as a code segment capable of dynamic loading and unloading with the kernel as needed. Okay. These modules enhance kernel capabilities without necessitating a system reboot. And that is something really cool actually. So you can write them and they are hot plug. So you can just like load them when you want. You don't need to reboot. That is really cool. And I think this is a feature of Linux as a I don't know how is it called, the opposite of a monolithic kernel. I don't think you can do that in a monolithic kernel. Yeah, I think it's gonna say it. The prevailing approach leans towards, in the absence of modules, the prevailing approach leans towards monolithic kernels, requiring direct integration of new functionalities into the kernel image. This approach leads to larger kernels and necessitates kernel rebuilding and subsequent system rebooting when new functionalities are desired. Yeah. Okay, Linux distributions provide the commands modprobe, int module, and diff module within a package. On Ubuntu Debian, okay, so I'm on Ubuntu, so let's start by getting all the packages that we need, like build essential and kmod. So they were already there, yes. Then, to discover what modules are already loaded in your current kernel, use the command ls module, these modules. What if I do it without sudo? Oh, okay. makes sense. Oh no. Wait a second. Why don't I see no modules? We can also try this. Oh, there is no module here. Why is it that? Yeah, here it is. WSL2 can't list kernel modules. This is expected behavior. The WSL2 kernel is monolithic and doesn't have kernel module installed. Oh my gosh. So that means I probably cannot do this from WSL. So I either need to move to my Arch laptop, which is not the best since it's pretty old, or probably I need a virtual machine. So I'm gonna work on that. Okay guys, I'm back on my Arch Linux distribution. Hopefully now I'm ready to start with this new adventure. So without further ado, let's go on. Let's start installing, I think I already have for sure GCC, but let's start with Kmod, which I'm pretty sure I also have already, but let's try anyway. Indeed, I did not have them. How is it possible? How don't I have GCC installed already? Okay, anyway, yeah, let's go on. Nice. So now we can start by showing which modules are already running in our distribution. And we have many. Like this crypto user, which is interesting. Okay, so we can there are a lot of modules. Okay, makes sense. Okay, modules are stored within the file proc modules, so you can also see them with sudocat modules. Okay, so I can also, why do I need sudo to, so it is like not even read-only for the standard user. Okay, so wait a second, let's go to proc. What's in here? Okay, these are like the processes, and then there should be, yeah, these modules. If I do like cat modules, I should get a permission error. No, I'm not, apparently. Okay, let's redirect the output to less. Sorry. Right, modules less. So yeah, maybe if we don't run it with sudo, we don't see every module, or maybe in Arch, like it is even read-only by the user. Let's try with sudo cat modules. I don't know, it feels the same, but anyway. To effectively follow this guide, there's no obligatory requirement for performing such actions. Nonetheless, a prudent approach involves executing the examples within a test distribution. Let's say this is a test distribution. I just want my OBS not to crash. which is not for now, so that's fine. Before we begin, before delving into code, certain matters require attention. Variances exist among individual systems, and distinct personal approaches are evident. The achievement of successful compilation and loading of the inaugural Hello World program may, at times, present challenges. It is reassuring to note that overcoming the initial obstacles in the first attempt paves the way for subsequent endeavors to proceed seamlessly. Okay, so mod versioning. A module compiled for one kernel will not load if a different kernel is booted. Sounds reasonable? Unless config mod versions is enabled in the kernel. Module versioning will be discussed later in this guide. Until module versioning is covered, the example in this guide might not work correctly if running a kernel with mod versioning turned on. Okay. Fine. we will just compile our module for the kernel version that we already have. Using X Windows system, which I am doing. No, I think I am on Wayland? I'm not sure. It is highly recommended to extract, compile, and load all the examples discussed in this guide from a console, which is not really what we are doing, because we are running it on X, on a terminal emulator and not directly from the console. But since I need to record this video, I don't have much alternatives, but yeah, I'll see. I hope that it will work. Modules cannot directly print to the screen like printf can, but they can log information and warnings that are eventually displayed on the screen, specifically within a console. If a module is loaded from an extern, what is extern? What is extern? Extern. Okay, sorry, I'm reading Italian. Is a standard terminal emulator from the X Windows system. It allows users to run programs which require a command line interface. If no particular program is specified, Xterm runs the user shell. An X display can show one or more user external Windows output. Okay. Anyway, yes, it's the standard terminal emulator. If a module is loaded from an external, the information and warnings will be logged, but solely within the systemd journal. These logs will not be visible unless consulting the journalctl, which I'm fine with it. Refer to for more information. For instant access to this information, it is advisable to perform all tasks from the console. I'm sorry, I will not do it. Secure boot. Numerous modern computers arrived with configure. Okay, I already know. My secure boot is disabled. It can cause problems if you use it. So yeah, I mean, if you have Linux distro installed and you are with a Wi-Fi system, you probably already disabled secure boot. I'm not entirely sure if you knew like Linux distributions and systems you can install Linux distros with secure boot on, but in my case I couldn't, so I just turned it off. Failing this, an attempt to insert your first Hello World module would result in the message error, could not insert module. Nice. Okay, before building anything, it is necessary to install the header files, of course. So I will not do the update because I already did it. Yes, let's install the headers, which I'm pretty sure I already have. Linux headers is up to date. So there's no need to install them. Okay. All the examples from this document are available within here. Okay. Okay, sure. The simplest module. Most individuals beginning their programming journey typically start with some variant of a hello world example. It is unclear what the outcomes are for those who deviate from this tradition, but it seems prudent to adhere to it. The learning process will begin with a series of hello world programs that illustrate various fundamental aspects of writing a kernel module. Presented next is the simplest possible module. Okay, let's make a test directory. Let me see. Okay, yeah, I'm in a proc. Let's go to, I don't know, there should be a programming. Yes. Yeah, let's make a directory here and call it, I don't know, just, yeah, kernel fun. I don't know, I'm not good with names. Let's just name it experimenting. It's too long, I'm sorry. Kernel experiments. Okay, so let's go here and then yeah, let's make this directory hello one. And here we should create this hello one.c. Okay, wait. So let's just copy for now. I'm not just copy and paste because I am a believer that you need to type in order to like learn something. Yeah, let's go on. Include Linux module.h, and this is apparently needed. Why I don't have syntax highlighting by all modules? This thing is bothering me. Why don't I have syntax highlighting? Wait a second. Oh shit. I think I have a problem with... Oh wait, let me use NeoVim. Same problem. Never mind. Then for this session I will use Nano, because I probably uninstalled like all the extensions on NeoVim and I need to... But what? It's not also here. Never mind, then let's just use Vim. That's strange. Okay. So let's go on. Let's import also Linux Kernel.h, and this is needed by PR info. Okay. What? Okay, I got what's the problem. Yeah. Okay, now I got it. I'm sorry. I didn't close the comment. That's why. Okay, then we start with this function init module. Which takes void and calls this PR info, which apparently just prints hello world somewhere. I suppose not the standard output as it was saying before. Unknown 0 return. means init module failed. Okay. Return 0. And then we have void cleanup module. Okay, let's just save it. We have this hello1.c. Now you will need a makefile. If you copy and paste this, change the indentation to use tabs, not spaces. Okay, sure. So let's create a makefile in which we write obj.m plus equal hello1.2 pwd dollar current directory all make -c lib modules dollar shall uname var /build equals, I don't know what I'm writing right now. I do know makefiles, but this syntax is I don't know what it's doing, honestly. Yes, I think this is mostly fine. And then we have clean, which does make -c lib modules dollar shell name r build equals, this is the same command. Oh no, okay. Equals dollar pwd clean. Okay. Makefile current directory can set to the absolute path name of the current working directory. I'm confused. Let's open the meantime GitHub, because I have created a repo for this somewhere. I will post the link, but yes, should be this. Because if I find, okay, yeah, I already saved this link. Yeah, if I find like useful links like this one, in which it explains everything about make, I will just save it for me and for everyone else like who need them. So wait, current directory, let's search. For your convenience, I'm gonna make starts. After that's processed any -c option, it sets the variable current directory to the path name of the current working directory. This value is never touched by make again. In particular, note that if you include files from other directories, the value of current directory does not change. The value has the same precedence it would have if it were set in the makefile. Okay. So it is like a constant that get assigned like one time at when make is executed. So what do we need it? What is this m equals? I don't know, that's too much. Okay, for now let's just save, and so now we have a make file and this hello one, that's it. Let's just make. Okay, I think it worked. If there is no pwd assign current directory statement in make file, then it may not compile correctly with sudo make. Because some environments variables are specified by security policies, they can't be inherited. The default security policy is sudoers. Okay. I will just skip this because it's too advanced for me. If someone has some more details about this, you can just write a comment. Okay. Here, if all goes smoothly, you should then find the check compiled lo1.ko. Yes, it is. Module. You can find info on it with the command module info. Module info lo1.ko. Yes, file name, license, source version, depends. Okay. Cool. Let's try it for ls module grep hello. Wait. No, it's not there. Should return nothing. Yeah, you can try loading your shiny new module with sudo insert module. Okay, let's try that. So now if we do again sudo this module, it's there, and it has a process ID, I guess. The dash character will get converted to an underscore, so when you try again, yeah. Let's remove it now. Okay. Okay. Notice that the dash was replaced by an underscore. Yeah. Okay. Let's see journal ctl and ins module. Hello world. So yeah, the module is correctly loaded because it prints what we told them to print. And then list modules, remove modules, and yeah, it correctly prints the goodbye message. You now know the basics of creating, compiling, installing, and removing modules. Now for more of a description of how this module works. Kernel modules must have at least two functions. A start function calls init module, which is called when the module is insmodded into the kernel, and an end cleanup function called cleanup module. Let's open again the source file. If I now do like make clean, yeah, nice. Yeah, init module and cleanup module. Things have changed starting with kernel 2.3.13. You can now use whatever name you like for start and end functions of a module, and you will learn how to do this, okay? In fact, the new method is preferred method. However, many people still use init module and cleanup module for their start and end functions. Typically, init modules either registers a handler for something with the kernel or replaces one of the kernel functions with its own code. Okay. Every kernel module needs to include Linux module.h. We need it to include Linux printk.h only for the macro expansions of PR-alert log level, which you will learn about in section 2. Honestly, I would like to see the implementation of that, and I had searched it in the past, but I don't exactly remember where they are. If you just install the headers, I'm not sure. Yeah, you cannot see, I guess, the implementation, I'm not sure. But you can install the exact source file of all the Linux OS, and it's somewhere in here. Let me try in dev. No. Wait a second. Kernel? No. I don't remember. GT user lib. No, I need to search it. USR source. Yes, Linux, here it is. So here, this is like heaven. You can find anything in here. If I go to include, I should be able to find somewhere the printk library. So the printk library, it's in the, where is it? Linux. I am already in Linux. So wait a second. Wait a second. Maybe it's not here. What if it's here? Yeah, I'm pretty sure it's here. So now if I open game, print. No, it's not here. Okay, let's go back then. Then it should be in that. Should be sources. Should be Linux. Lib, maybe. No. Then it's include. And then here again Linux, I think. Yes. Exactly, now it's here. printk.h. Yep, here it is. And this is wonderful. Here you have like the entire definition of all the functions used in the Linux kernel, and that's just beautiful. So let's try to see, let's make this a bit bigger. Oh no, yeah, I'm sorry, this is my lo-fi place. That was awkward. Anyway, so let's see, for example, if I search for this function that we use, prinfo, wait, no, sorry, prinfo, no, what are you doing, how do you undo? PR info. Okay. PR info. Here it is. So this prints an info level message. This macro expands to a print k with kern info log level. So yeah, it is like a macro fmt and this, which I don't know what does it mean. I don't even know how macros are declared in C and how do you use them, but I do know that basically this function is just a wrapper for print k. So if we just search print k in here, print k, and then we go how do you go back in searching here? Not this, definitely. Let's go to the start of the file, but it should be like around here. Dummy print k. Wow, there are a lot of print keys. No, wait a second, I need to find this print k. This print k is itself another macro for this print k index prop. Oh my god. Okay, it's a bit difficult, but yeah, basically here you can find everything. And it's awesome. It really is awesome. So now let's make this smaller again. Okay. Let's go back to my place. Yeah, kernel. Okay. So where are we? Yeah, we can see this. I want to see this, honestly. These macros are defined in include Linux module.h. So if I go to dynamic loading of modules into the kernel 2002. That's just crazy that this stuff was like written in 2002. I'll just put full screen for now. Basically we have to search for these module init and module exit functions. Module init. No. Module init, driver initialization entry point. Function to be run at kernel boot time or module insertion. Module init will either be called during do init calls or at module insertion time. Define module init is init call. Yeah, so this is another macro for this init call. So now we'll search init call. Init call, yes, here it is. Oh no, init call. What? This init call is just here. Wait a second. So this init call is not declared here probably, and it's somewhere else. Init probably, I don't know. You can see what's in init. Built-in functions didn't be compiled with report line. Wow, that's a lot, like, really fascinating. But yeah, I'm not searching. I wasn't searching for that. I think I need either to use VS Code for this or to install some extension to NeoVim, because I want to go to like the definition of some functions, but I want it to be automatic, and I don't know how to do it right now. So with VS Code it's just simple, you just do control mouse click, left click I think, and it brings you to the function definition in other files. So I need to search if something like that is possible in Vim, because it would be really useful. Like it's impossible to search for a function definition like this. If you do know other methods, please tell me, because I really would like to do it. Anyway, let's go on. Let's close here. Ah yeah, it calls this in it. What? A second. Ah, okay. Let's see here. Like if I go here. And for example, I want to init module. Okay. Yeah, let me see this init module. How can I find it though? I can't. I mean, I can do it here, but yeah, it's not much different than do it in my terminal. don't know. I'm pretty much confused right now. Init.h, needed the macros. Okay, anyway, let's modify our code. So now we should also include init.h. Okay, and then let's just use basically static and init hello. This is another file. Oops. So let's just not save. Right? Yep. So let's do the hello. Let's just copy. Okay. So then, yeah, here let's just. Oh no. Okay. Anyway. But wait on a second. I do need to create another, I guess, yeah, another folder. Yeah, so I will just create another folder. And then I will move. Let's go back to hello1. Sorry. I will just move hello2 dot c to hello2. Yeah. So it's not here anymore. I need to. Sorry. Hello2. Yeah. We'll also create a make file since we need it. Okay. Okay guys, I think for today it's gonna be it, and yeah, from the next video I'm gonna continue with the second module, and I hope I will have figured out how to set up like some extensions here in NeoVim and how to use it better, because it's my first time, and yeah, it's my first time using it and I'm not that good, honestly. And yeah, I think that's it. Hope to see you soon. Goodbye.